Okay, so I've got no idea how I muted myself there. I think my book must have pressed my touchpad. Okay, so we'll keep the book off my computer. Okay, so like I said, this is the last stretch for theory, learning unit 7, then we're done and dusted. And then it's just practical for the balance of the year, which is great. So learning unit 7 is all to do with internet and World Wide Web, a little bit of theory on how that all works. It's all very interesting, and when you start digging into it, you'll see it's actually there's a lot in here. Okay, so they start off by asking here, what is the internet? And essentially, the internet is if you need to ask a question at any stage, just unmute your microphone and go for it. Okay, so what is the internet? The internet is basically all of the hardware. It's everything that connects the whole global network together. So it's your laptop or your PC, plus your Wi-Fi router, plus if you've got fiber, there's what they call a fiber optic transducer or transceiver that takes the light signal and converts it back to an electrical signal that your Wi-Fi router can understand. Then it's all the equipment at the telecom offices. It's the satellites, it's everything. It's everything that you need to connect all of these devices around the world together. So that's what the internet is. The internet is sort of the sum total of all the hardware. Then on top of that, okay, so on top of all that hardware, that's just the transport layer, whether it's bounded media or unbounded media. Unbounded, obviously wireless. Bounded means stuck inside of a cable, fiber, or coax or UTP. And then on top of that connection, on top of all of that network, we have services, the actual software that's running on top of all of that. Okay, so if we look at some of the basic services we get, obviously nowadays a lot of it is to do with cloud storage. We all know what cloud storage is. Why the cloud? Who can tell me quickly? Why do we call this the cloud?
Because it's not like a physical thing on land. It's like everywhere around us, above us, or everywhere.
Yeah, because it's sort of you'll often see when people draw this, when you see a drawing of this, you'll see like your house, and you'll see like a wire leaving your house and into this like nebulous cloud thing. It's basically just saying that it's somewhere. So if you save some, like for instance, I and you all have it as well. You've got OneDrive. We have no idea where those files are saved. They're probably going to be sitting in some server. I know our teams comes from Western Europe, so it's probably sitting in some data warehouse, a server sitting in a rack somewhere in a big fat warehouse in Germany. For all we know, we just don't know. It could be anywhere in the world. We just know that we can connect to it and use it. So that's what the cloud is. It's kind of this just nebulous thing as to where your stuff could be, and in fact we don't care. We just use the service and we don't care where it all goes. There's obviously a lot of benefits to using the cloud. You can read all that. Obviously you don't have to buy the equipment, you don't have to hire technicians to look after the equipment, no one has to configure it for you, and you just pay to kind of use what you want. Think of it as like Uber for data, right? Uber, you just, when you want a car, you just use your phone, car comes, picks you up, and when you get out, you just pay for what you use. Same thing with cloud storage, or even cloud computing. You just pay for whatever you use, and then you move on. Okay, there's some things you've got to watch out for. Of course, cloud computing really falls over if you don't have a very good internet connection. And then obviously there's issues around security. What happens if your stuff, it's much easier for your stuff to get hacked, I think, if it's online. What happens if they, like they say, you have the company that's hosting your stuff, if they have a catastrophic failure? What happens if their data warehouse catches on fire and all those servers burn? Big problem. Okay, so cloud storage is one service that runs on top of the internet. Another one, very common, obviously, is email. Been around for years and years and years. One of the very first services that were running on the internet. You can read it up there. There's three main, what we call protocols. A protocol, think of it as like a language. All of us around the world, we can speak. Okay, people that speak English can communicate with each other. Okay, I cannot speak French, so people that are speaking French, they're able to communicate with each other, but I don't know what they're saying. It's a bit like that on the internet. There are different protocols for different things. Protocol, think of it as being a language. So there's an email protocol, there's a web protocol called HTTP or HTTPS if we're using secure web. So that is a language. And then with email, there's a couple of languages. There's one called SMTP. Okay, so SMTP is a simple mail transport protocol that deals with sending your mail. So when you hit send, it uses SMTP. That's the protocol it uses to send your mail from your laptop or wherever you are to the mail server. Then there are two mail protocols for receiving mail. There's the first one that came out was called POP or POP3 for Post Office Protocol. And that physically downloads the mail from your mail server to your machine. So the mail leaves your mailbox and comes to your machine. And the much newer protocol that came around really with the advent of things like Blackberries and phones, that you didn't really want to download your mail. You wanted to have a look to see what mail was there. So it allowed you to look in your mailbox. So you could like open your mailbox, look what was inside, but you didn't actually have to physically download all the mail. Okay, you could just look at the mail you wanted to look at. Okay, and that's called IMAP, IMAP, or IMAP4 is a newer protocol for email. So that's the email service, POP and IMAP, and SMTP for sending mail. Then we got websites. Obviously, we use those all the time. Everything is web related nowadays. We're on a website, right? Well, I'm using a Teams app, but ultimately you can use this on the web as well if you want to. Then we're looking at IP addresses. So IP address, we've all seen these before. An IP address is basically a 32-bit address split into 4 8-bits. We know that 8 bits we can have between 0 and 255. So you can get an address anywhere from 0.0.0.0 all the way up to 255.255.255.255. So that gives us 2 to the power of 32 possible addresses. And it seems like a lot, but in actual fact, they're all used now. Every single address that's possible in what they call IPv4, the system of IP addresses that we use on the internet currently, have all been handed out. There's no free ones left at all. So the world is a big problem because it's run out of internet addresses. And they are moving to a new system called IPv6, which they've been doing for several years, but it's been very, very slow to roll out for some reason. I don't know. It'll probably pick up now because they're out of addresses. We've all seen these sort of addresses before. It's something.something.something.something. And that address uniquely identifies you on the internet. It's like your phone number. So it's like your internet phone number almost. Okay, so you can start reading through that to see how that works. And we know that the internet as well is a big, huge interconnected. I'll show you how everything is all interconnected. Let me just share my screen here quickly with you. I'll just share my desktop. Let me just share my desktop with you. Okay, so I'm just going to open up a DOS box here. I think you've all done that before. Just CMD or command, COMMAND. That will open up a DOS box for you. And you can say, type in here, let's say, I want to trace a route from where I am right now, and I want to go to, let's say, Dropbox, because I've got a cloud storage. So I want to trace a route from me to Dropbox. And now what my machine is doing is, you can see there's my IP address. There's Dropbox's IP address, 162.125.248.1. Okay, so somewhere in the world, that address is sitting on a server somewhere. Now this is me here. Okay, you can see I'm with AfriHost. That there is my IP address, and you can see us jumping through different routes here. So it's going from that address. So my machine is basically sending a signal to Dropbox there and bouncing it back, and it's measuring the time. You can see it here in milliseconds. Okay, so you can see here is AfriHost. Then I jump to Telcom. Okay, then I make the hop to overseas. You can see all of a sudden here, my ping times are up from 5 milliseconds up into the 180 plus, because now that address 10.189.30.10 is going to be overseas somewhere. And you can see I've jumped onto Cogent's network. They're a huge level 1, a tier 1 internet provider in the world, really, but largely in America. And so you can see the different routers that my signal is bouncing through. So I'm going through 10 routers until I hit Dropbox over there. So that shows you how far you're going. Let's say, for instance, you want to have a look to see how do you get to Netflix? We all use Netflix, right? So here's the route from my house now. So there's Netflix's IP address. Okay, so there's the human readable form, netflix.com. Here's their IP address, and you can see now it's bouncing through. I've gone through AfriHost, Telcom again. I've made the hop to overseas. I'm on Cogent's network. Yeah, so there I'm in London, LU7. Then I jump to New York, JFK. Okay, so you can sometimes work out in the what they call this an FQDN, fully qualified domain name. It takes the IP address and puts it in the longhand English version. So you can see London, JFK, and it's still working its way. These ones that are stars means it's given up after 3 seconds. Some routers just will not answer ping requests. So it tries 3 times and then gives up and then moves on. So you can see how many hops. Okay, each one of these is called a hop. You can see how many hops you have to take until you reach Netflix. Okay, I'm not going to let it go here. You're getting the idea of what's involved. I'll just stop it, but I think there's something like 25 hops. It's quite amazing. Okay, I'll just pull back my screen here. Okay, so that's, you can read on IP addresses and how they work. Okay, we've got, like I said, we have these languages. The language of the internet is called TCP/IP, or Transmission Control Protocol, Internet Protocol, and that is the language that determines how network cards, how information gets sent from your network card to the next network card, and how the internet shares data at its lowest level. It's the basic low-level language of the internet, TCP/IP. Okay, and you can have a read about that. Once we get back to class, I will go through a little bit. Once we can write on the board and things are a bit easier, I'll go through a bit more about the theory about IP and TCP/IP and how it actually works. But you can, I think you can see it. That trace route thing that I did, you can try that on your own machine even. TRACERT, trace route. You can trace route anywhere you want, and it will show you how many hops it is to whatever destination address that you put in there. Okay, so 7.4, what is needed to connect to the internet? Okay, obviously we need some hardware. We need a network card. That network card could be a network card that's taking a physical cable connected, a UTP connection. Back in the day, a couple of years ago, it could have been a coax cable, like old TV cable, like a TV aerial type cable. Or it could be, you could have Wi-Fi built directly into your laptop, or you could have like a little USB Wi-Fi dongle that you stick into a USB port, and that will provide you with Wi-Fi for your laptop or your PC. So you need So you obviously need a network card, something that can talk TCP/IP, and that can connect to a Wi-Fi router or into your home router via a cable. Okay, so that's what you need at a minimum. Then in your house, you're going to have some sort of a router. A router basically just it routes, as its name suggests, it routes traffic between its different ports. So it works out, say for instance, you and your mate are sitting in your house and you're playing a game. It knows that the traffic is just between you and your mate. So it doesn't bother sending the traffic up the internet. Okay, unless you want to access a web page, then that traffic goes up the internet. So think of it as being a bit of a traffic cop. Okay, it controls the flow of traffic on your network. That's pretty much what a router does. It routes, as its name suggests. Okay. You also get things called switches. Switches are a bit dumber than routers. A switch, its sole job is just to connect stuff up. It has no idea where the internet is or anything like that. It just switches between ports. That's all it does. A router is one layer smarter than a switch. And then back in the day, you used to get what they called a hub, and a hub was even dumber than a switch. Okay, so it just literally just joined the cables together and made sure that you could have the right length of cables and things like that. Okay, we will go through those sort of the difference between hubs, switches, routers, etc. When we get back to class. So you can go through there what you need in terms of hardware and software, types of connections. Okay, so I'm up to 7.4.2 on page 88. I think most of us are familiar what ADSL is. ADSL is like what I used to have here at home, or asymmetric digital subscriber line. It worked on what they call POTS, P-O-T-S, plain old telephone system, just copper wire, just a normal copper wire, plain phone line. That's what you needed for ADSL. And ADSL, the A part, that was the sucky part of ADSL because it's asymmetric. It meant that your download speed was different to your upload speed. Okay, so like mine used to be, I used to have 4 megabits download speed, but my upload speed was not even 1 megabit. I think it was 765 kilobits or something, very low, but that doesn't really matter because you often don't send stuff. You normally download a lot more than you send when you're using the internet. Okay, so that's ADSL. Lucky I managed to get rid of ADSL. I've now got 20 megabit fiber here at home. So I got 20 megabits down, 20 megabits up, which has been a godsend for me, no doubt about it. As soon as you move to fiber, obviously you're no longer using copper. So with ADSL, your distance from the telephone exchange played a big part in the speed that you got. So if you lived a long way from the phone exchange, you wouldn't get very good speeds. If you lived very close to the telephone exchange, you got very good speeds. But with light, that's not a problem. So I get 20 megabits solid on my fiber connection. Then wireless, we've done wireless before, Wi-Fi, we kind of know how that works. And then cellular, obviously, if you're using Vodacom or MTN or Cell C or any one of the providers, that's giving you 4G or whatever speed you're getting now. I don't think 5G is around much yet, but 3G if you're unlucky. But that's the cellular side. Okay, World Wide Web, www. This is one service that runs on the internet. Okay, a lot of people, especially the younger kids, when I was, lower grades, if I say to them, "What's the internet?" they'll straight out say to you, "Oh, it's Google." And that's not what it is. Okay, the internet's not Google. Google is just a company. They're not the internet. They're just a lookup table. Okay, they're like a big telephone directory. That's all they are. So World Wide Web, www, that's one of the biggest services on the internet. Okay, that's obviously how we get web pages served for us. And it's a client server kind of thing. There's a server sitting somewhere that's running software that's listening for you to connect. Okay, so that's the server part, and you are the client part. So whether you're using Chrome or Firefox or Safari, that is a client, a web client. that's busy just downloading text. I think I've shown you this before when we were making HTML, we're making web pages at one stage, and I showed you that's just text that comes from a web server. It's your browser that converts that plain text into a nice looking page. Okay, so a URL, that's the name. That's the thing you type into the bar in Chrome, www.google.com. That's a URL. Okay, a uniform resource locator, or sometimes people call it a universal resource locator. It's its unique name in English, pretty much. Okay, so a URL, that's what it stands for. Okay, so then they go through about searching the web, web browsers. We've done a lot of this, I think, before. You can read through this, what search engines are and how to use them, and how to search successfully. Okay, let's just see what else we've got here. Okay, I will stop the live feed here. You can carry on, just have a read through here as well. They go on to searching with logical operators. Obviously, we've just done a section on Boolean. Okay, so you can use that or and that and in your searches on Google. You can actually put and or and not in your search. If you, in fact, go and have a quick look at some stage and see how you can do advanced searches on Google. You really can narrow your search down from millions of hits down to really just what you want by excluding stuff as well. So you can use and or and not in searching on search engines. So you can read through that section as well. I will take it that far. Okay, are there any questions that we've got up to now?
Yes, sir.
No, sir, I'm good.
Okay, let me turn the recording off.
Thank you, sir.